Hi everyone. Today we're going to study modular exponentiation. Modular exponentiation is the remainder when an integer b, the base, is raised to the power e, the exponent, and divided by a positive integer m, the modulus. That is, c equals b raised to e mod m. From the definition of division, it follows that c is between 0 and m. Modular exponentiation is useful in computer science, especially in the field of public key cryptography, where it is used in both Diffie-Hellman key exchange and RSA public/private keys. In solving modular exponentiation, that is c equals b raised to e mod m by direct method, we can use calculator and derive the desired value of c. This method has limitation such that b raised to e must be a small value. Example, solve c equals 5 raised to 4 mod 9. Using calculator, this value 5 raised to 4 is equal to 625. Remember that c is the remainder when 625 is divided by 9. So, c is equal to 4. This is our answer. Solving modular exponentiation, that is c equals b raised to e mod m by binary method, is used when b raised to e is a large quantity. Example, simplify c equals 5 raised to 41 mod 9. We note that the b is equal to 5, e equals 41, and m equals 9. For our step 1, we will write the value of e that is equal to 41 into binary. Remember that the operation is like this. 41 is divided by 2. The quotient is 20 and the remainder is 1. Next, this 20 we divide by 2. The quotient will be 10 and the remainder is 0. Next, this 10 we divide by 2. The quotient is 5 and the remainder is 0. Next, 5 divided by 2. The quotient is 2. The remainder is 1. Next, 2 divided by 2. The quotient is 1. The remainder is 0. When the last number is 1 here, we stop. Then the binary value will be this number 1 and the numbers of the remainder column, and we copy it going upward. So, we write 41 is equal to this number 1, 0, 1, 0, 0, 1, base 2. Remember that in our binary table, this number 1 here corresponds to 32, the number 0 for 16, 1 is for the 8, 0 for the 4, 0 for number 2, and 1 for number 1. Step 2. Express 5 raised to 41 into binary exponential values. It means, using our table here, we write like this. 5 raised to 41 is equal to 5 raised to 32. See here that there is a value 1 for 32. Times 5 raised to 8. We can see also that there is number 1 with respect to this value 8. Times 5 raised to 1. There is number 1 here that corresponds to the number 1 on top. Step 3, we evaluate 5 raised to e mod 9, where e is a binary value. Let us write again our table on top here. So we're going to evaluate this modulus, starting with 5 raised to 1 mod 9, 5 raised to 2 mod 9, 5 raised to 4 mod 9, 5 raised to 8 mod 9, 5 raised to 16 mod 9, and 5 raised to 32 mod 9. Let's begin with the first one, 5 raised to 1 mod 9. We can simplify this into simply 5 mod 9, and this is simplified into 5. For the remaining modulus, we are going to use an identity modulus, and it will be like this. So that is the quantity A times B times C, then mod n is equal to the quantity A mod n times B mod n times C mod n, then mod n. Let's begin now with 5 square mod 9. Considering our first modulo here, we can write 5 raised to 1 times 5 raised to 1 mod 9. Then we use our identity. We can write like this, 5 raised to 1 mod 9 times 5 raised to 1 mod 9, then mod 9. We can get the value of this 5 raised to 1 mod 9 from the first step. We can see that the value is 5. We can substitute the number 5 in here, respectively. So we have 5 times 5, then mod 9. 5 times 5 is 25, and 25 mod 9 is simply 7. Then we go to the next modulus, 5 raised to 4 mod 9. Considering our previous step, we can write this 5 raised to 4 into 5 square times 5 square, then mod 9. Using our identity, we can express this into 5 square mod 9 times 5 square mod 9, then mod 9. This 5 square mod 9 has the value in our previous step, which is 7. Let us substitute the number 7 respectively. So we have 7 times 7, then mod 9. The product is 49 mod 9, and we can simplify this into 4. We go to the next modulus, 5 raised to 8 mod 9. We can rewrite this into 5 raised to 4 times 5 raised to 4, then mod 9. Using our identity, we can expand this into 5 raised to 4 mod 9 times 5 raised to 4 mod 9, then mod 9. This 5 raised to 4 mod 9 has the value from our previous step. The value is 4. Let us substitute that number 4 respectively. So we have like this, 4 times 4, then mod 9. The product 4 times 4 is 16 mod 9, and the value is equal to 7. Next modulo, 5 raised to 16 mod 9. We can write this into 5 raised to 8 times 5 raised to 8, then mod 9. Then we use our identity. So we write 5 raised to 8 mod 9 times 5 raised to 8 mod 9, then mod 9. We can get the value of this 5 raised to 8 mod 9 from the previous step. The value is 7. Substituting the value 7 respectively, we have now 7 times 7 mod 9. The product of 7 times 7 is 49 mod 9, and we simplify this into 4. Next modulo is 5 raised to 32 mod 9. We can rewrite this into 5 raised to 16 times 5 raised to 16, then mod 9. Let us use again our identity. So we have 5 raised to 16 mod 9 times 5 raised to 16 mod 9, then mod 9. Let us substitute the value of this 5 raised to 16 mod 9 from our previous step. The value is 4. So we substitute it like this, 4 times 4, then mod 9. The product 4 times 4 is 16 mod 9, and we simplify this into 7. So we are done with step 3. For step 4, using binary values, we are now to evaluate 5 raised to 41 mod 9 is equal to the quantity 5 raised to 32 times 5 raised to 8 times 5 raised to 1, then mod 9. Let us copy this right side value down here and let us use the identity. We can rewrite this into like this. 5 raised to 32 mod 9 times 5 raised to 8 mod 9 times 5 raised to 1 mod 9, then mod 9. We can get the values respectively from our step 3. So this 5 raised to 32 mod 9 is equal to 7. This 5 raised to 8 mod 9 is equal to 7. This 5 raised to 1 mod 9 is equal to 5. So 7 times 7 times 5, then mod 9. We can observe here that we can combine this 7 times 7. Then we will get 49. So it will be 49 times 5, then mod 9. We intentionally multiply 7 by 7 first because we can see in our step 3 that there is a value of 49 mod 9 in here. Now let us continue with our steps. Let us now use our identity from here. So we say that this 49 mod 9 times 5 mod 9, then mod 9. The value of 49 mod 9 is here, that is 4. And the value 5 mod 9 is 5. Then we write mod 9. The product 4 times 5 is 20 mod 9, and we simplify this into 2. This is the final answer. I hope you learned something from this video. See you again next time.